Morning. Today's lesson is on length of daylight also, same as yesterday, but it's in Winnipeg, not Philadelphia and Houston. Let's get right into it, folks. Let's get right into it. All right, good things. Got a tennis tournament today in Madisonville. I won't be in the school, but you'll have this to look at. You'll have a good sub to help you out, and I will finish grading all of the poster projects for the Ferris Wheel tonight when I get back. That's always a good thing. Actually, if you think about it, before you go to spring break, you'll have all your major grades done for the 6 weeks. And if you've done well, you can actually, I would suggest you take the test after spring break just so you have one you can drop. But if you did well enough on your 3 majors, you probably don't need to take it again. So let's get right into it. Part C, Winnipeg. Let's make a scatter plot of length of daylight by number for Houston on the blank grid provided in class. I'm not going to go into this like I did the other ones. I want you to do this in class as part of your project. The information here, I need you to go ahead and do the scatter plot right over the top of where we have the scatter plot for Houston and Philadelphia. We'll go into some detail about how to do sinusoidal regression on the calculator today, and that's the majority of this lesson. All right, like I said, you want to connect the scatter plot points. This is something you're going to complete on the handout for your project. I'm not going to go into it. We're going to enter the data into the list, and as you can see, I've already entered the data into the list here. You can see you're going to do stat, then edit, and enter your data in. Notice that L1 and L2 are used for Houston. L3 is used for Philadelphia, so we need to use L4 for Winnipeg. All right. Use calculator, make a scatter plot of length of daylight by day number for Winnipeg using L1 and L4, and sketch your graph and describe your axis and scaling. Notice it plots right over the existing Houston and Philadelphia scatter plot when you graph. This is what it looks like when you're done. I'm not going to ask you to do it. This is what it should look like when you're done. We're going to go into this and show you how it's done. We're going to complete this on the handout for your project. All right, so let's do that now. Let's go ahead, and this is the Houston and Philadelphia stuff. We're going to check using information, but we want to use the information for Winnipeg instead. So I've already, I'm going to pull up the Winnipeg information right here, and I'm going to plug it into my calculator into L4. So since L1 is the day number already, I'm just going to go ahead and put in the times for daylight minutes for Winnipeg. 492 on day 1, 63 for day 32, and we'll just go on and put these in here real quick. 83, 964, 975, 911, 808, 697, 586, and 505. And notice they all correspond and they end at the same one. It wouldn't work if you didn't do this the right way. So in order to go ahead and do this regression function, we need to pull down to where we're supposed to be at, right here. I put Winnipeg in there, but I'm not going to do that. Let's do a regression for Houston, and then we'll do a regression for Philadelphia, and we'll check our work. So I'm going to go stat calc. Notice that in stat, I'm going to hit stat, and then I'm going to arrow over to where it says calc right here. And then I'm going to scroll down until I find sine regression. And it's right below logistic. Okay, and it's going to ask you, what do you want to use? So I want to do Houston, and Houston's in L1 and L2. And the way you change this from whatever it is to whatever you want it to be, you're going to hit second, and you're going to look down here for the L functions. I want L2 here, so I'm going to put 2. Then I'm going to scroll down until I get to calculate and hit enter. And then when I enter, I'm going to get this function, 113,259 times sine times the quantity 0.01679 blah, 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 x plus a minus 1.3188. And then at the end of that quantity, we're going to add 727.47. Now, if you look carefully, you'll see that that is exactly the calculator form we got. Now, in order to factor the b, all we have to do here is we have to take, notice that b is multiplied by x inside the quantity. So we want to take the b outside of the quantity and leave x plus c divided by b. That is because when you calculate, you got to take a b out of both the terms. It's easy to do it out of this term in the quantity because that b is already multiplied by a variable. So we just take it outside of the term. In this one, we actually have to take the b and divide it into c. In this case, c is negative 1.31. We divide it by 0.01679. And if you check, so it is 1.32, and actually it's negative 1.32, and we're going to divide it by 0.017. We got negative 77.64. If you look at the calculator version, that's exactly what we subtract x by, minus 77. Okay? And from that information, we can actually put this into the y equals. Now, if you graph right now, we have all three curves in a scatter plot. Now, I also want to mention that if you don't know how to turn your stat plot on, you have to go second, y equals, and make sure you turn these on. Now, I want you to notice in here that I've changed the second column for each plot. The blue plot, it is for Houston. The red plot, it is for Philadelphia. And the black plot is for Winnipeg. Those are all the three columns I have in the stat edit. Okay, I have the letters or the daylight times for Houston, Philadelphia, and in this case, I also have what is called Winnipeg. All right, so I'm going to go back to y equals, and I'm going to put this function in for y equals 113.26. And then I'm going to use my sine function right there. And then I'm going to multiply by 0.017 and plug in an x. You have to hit this. You can't just type x. Minus 1.32. Close the quantity and then add the 727.37. Now, when I graph it now, it'll also graph that curve. And notice that it follows very closely, right on top of all those lines. We can do the same thing for Y2. We'll put in the calculator form for Philadelphia. Now, if you want to, we'll go stat, calc, and we're going to go ahead and do sine regression, and we're going to find Philadelphia's regression function. So we're going to go second and change that to L3 right here, which is the number 3. Now when I calculate it, it will give me the regressed formula for the sinusoidal function for that one. Notice 168.44 sine times 0.016, that's in there, 0.017, they rounded x, minus 1.29, close, plus 76.06. That's exactly what we have here. We'll go back where were we? Right there. Okay, so let's go ahead and put that into y equals on our y2 and see how that looks on top of the graph. 168.44 sine quantity 0.17 x minus 1.29 closed quantity plus 726.06. Did I do that right? Yes, I did. Okay. So now when I graph it, I've done something wrong. Let's go back, and I bet I made a mistake on the y equals function. And I think I did. Watch. Looks like I did everything right. Oh, look right here. Notice in the Houston function, it's 0.017, but in the Philadelphia section, it's 0.17. That's a clerical mistake. That's a keystroke error. So I'm going to insert an extra 0 in there where it's supposed to go, and that should fix it. And let's graph, and lo and behold, there's Houston, and there's Philadelphia, and it goes right along. So now that you see how to do this, you should be able to do the Winnipeg one it'll give you a good idea of how to do the rest of them too. When you do Porto Alegre also, it'll help you do that. So let's continue on with this slideshow. Now that you see how to really well, now you see how to make that graph really well. It should be really simple. Use your calculator to determine the minimum and maximum values. You're going to do this on your handout. Do the same thing for minimums. Please complete this on your handout. How does the maximum length of daylight for Winnipeg compare to the maximum length of daylight for Philadelphia and Houston? Well, the maximum length of daylight for Winnipeg is greater than the maximum length of daylight for both Philadelphia and Houston. Is that always the truth? Yes, it is the truth, the maximum length of daylight. And that's because the height of the latitude there is where it gets its sun. How does your answer to question 7 compare to the prediction? So we predicted that Philadelphia would have more sunlight or less sunlight than Houston in the summertime, and we found out that was wrong. And we also found out that's the same for Winnipeg, that there's more sunlight in the summertime. We'll complete this part also. The numbers you need to get for the maximum and the minimum. Intersection, same thing. You're going to have to find the intersection on your own. You're going to complete this for the handout. This is part of your project. So let's talk about something real quick. The town of Seward, Alaska is at 60 degrees north latitude. That's just south of Anchorage. Now, what do you expect the length of daylight during the summer months to be like there? And what would you expect the winter months to be like? So let's look at it. During the summer, Seward should probably have more daylight than Winnipeg. Since Winnipeg has 16 hours of daylight, Seward should have more than 16 hours of daylight during the summer. Furthermore, during the winter, they should have less daylight than Winnipeg. Winnipeg's least amount of daylight in the table is 492 minutes, 8 hours and 12 minutes. So Seward should have less daylight than that for the shortest day. Now, I want you to think about this for a second. How many of you have actually seen or heard about some towns in Alaska that have no sunlight for several months, and they have nothing but sunlight for several months? We'll talk about that at the end of this project, and it'll be a bonus section for you to work on if you wanted to. All right, what relationship do you think there is between a city's latitude and the amount of daylight it receives throughout the year? And this should be really simple. We can easily surmise from this exercise that the greater the latitude north of the equator, the longer the days during the summer months and the shorter the days during the winter months. And that's true. And actually, it's the same south of the equator. The further south of the equator it is, the longer the winter months, the longer the days are during the summer months, and the shorter the days are during the winter months. And how is this application of the sinusoidal regression in latitude is related to length of daylight, similar to the model to the Ferris Wheel Project? Could a sinusoidal function be determined by using the sinusoidal regression model for the Ferris Wheel Project? Yes, absolutely. We can see that using the time and height of the gondola, a sinusoidal regression could have been determined very easily. All right, I'm going to launch you the same way. This is a really quick, easy lesson. You have the handout for Winnipeg. I need you to work on it. There is going to be an assignment in the Google Classroom for Winnipeg for you to go over. It just needs to be something that you can determine by doing the project. Real quick, 5 easy questions for a daily assignment. All right, folks, get on those assignments, stay on the project, do what the sub tells you, be blessed, and be a blessing. Peace out.